Okay, time to switch gears again. So we've done linear, we've looked at quadratics. Now we're going to do a very, very brief look at exponential functions, right? Exponential functions are exponential because their variable is in the exponent, all right? That's where we get the exponential from. Okay, so the first thing we got to do is look at some exponent rules, all right? So these are rules that you're going to have to remember anytime we're working with exponents because we use them to simplify our expressions. So if I'm multiplying and I have the same what we call base and different exponents, right? So my base, it's always going to be the base to an exponent, which we'll just write exponent. All right, so the base is down here on the bottom, raised to the exponent. So here, my bases are both x. So if I have the same base, I can multiply and I end up adding my exponents, okay? And the reason being is because if I did like x squared times x cubed, okay? X squared is the same as x times x, right? And I'm taking that times x cubed, which is x times x times x. So now I really have x 5 times, so that's x to the 5th. So that's where our rule comes from. But you have to remember, if you're multiplying with the same base, you add your exponents. And then the same idea, if I'm dividing, I subtract. All right, and that one, let's see, scooch over, I don't have a lot of room here. But if I'm doing, we'll do x squared divided by x, right? That's the same as x times x over x. X's are going to cancel, and I'm left with just 1x, which is 2 minus 1, right? Because that's to the first power. So I'm left with just x to the first power. All right, now if I have a base raised to a power, and that whole thing is raised to a power. So if there's parentheses between my exponents, my rule is that I multiply. So it's going to be x to the a times b. So if I had x squared cubed, right, that's the same as saying x squared times x squared times x squared, because I take it times its, times itself 3 times. Well, with the rule we just looked at, we said that we add our exponents, so that becomes 2 plus 2 plus 2, which is x to the 6th. So that means I could have just done 2 times 3, so you multiply. All right, x to the 0, no matter what. If I have something to the 0 power, right, like I said, x squared was x times x. Well, to the 0 power means I have no x's there, so it's 1. Anything ever raised to the 0 power is just 1. Okay, and then the last one that we're going to focus on is if I have a negative exponent. It's bad math grammar to leave a negative exponent, so we're going to have to make it positive. To make it positive, you move it to the top or to the bottom. So for example, this one is the same as 1 over x to the positive a. But it works that way for anything. So like if I had, we'll say 2 over 3x to the negative 2. I can't leave that negative 2 on the bottom. So I'm going to take the x to the negative 2. Now only the x, because 3 doesn't have that exponent. They're different. But I'm going to take my x and move it up. So this becomes 2x to the positive 2 over 3. So that's probably our trickiest one, is working with those negative exponents, okay? But 5 main rules. If you multiply with the same base, you add. If you divide with the same base, you subtract. If there's a parentheses between, so you have a power raised to a power, multiply. Anything to the 0 power is 1. And to make a negative exponent positive, you move it up or down based on where it is in your fraction. All right, got some examples to work on with these exponent rules. All right, when I'm working with exponent rules, the adding and stuff only goes to the exponents, right? So like I have 2x squared times 3x cubed. I'm going to multiply the 2 times 3. Those aren't exponents. I don't have a base raised to an exponent there. Those are kind of separate on their own. So 2 times 3 is 6. Then I'm going to use my exponent rules for the x's, because those are the ones that have exponents. So x squared times x cubed, I add them, and we get x to the 5th. So my answer is 6x to the 5th. Right? For number 2, I got division. So for my exponents, I'm going to subtract, but again, 8 and 4 are separate. They don't have exponents. So I'm just going to do 8 divided by 4, which is 2. And then I can subtract my exponents. 5 minus 2 is 3. So we get 2x cubed. For number 3, right, we've got all of this raised to the second power. So I am going to be using my rule that says to multiply. But before I do that, I have to take this 2 and distribute it to everything in this parentheses, right? So this is 4 squared, right, times x squared squared times y cubed squared. 4 squared is 16. If I have, a power raised to a power, I multiply. So that's x to the 4th, and then 3 times 2 gives me y to the 6th. So my answer is 16, x to the 4th, y to the 6th. Okay, for number 4, got some multiplying here, but again, the numbers aren't raised to any powers, so those are going to kind of be separate. 2 times negative 3 is negative 6. Okay, now I have x to the 1st, I'm going to write it up here, times x to the negative 1. So I can add those. 1 plus negative 1 is 1 minus 1. That's going to give me x to the 0. Then I have y squared times y to the first power, right? If nothing's there, you can assume that's a 1. And I can add. So 2 plus 1 is 3. I'm almost done, except for this 0 power in here. It's such a weird looking thing because you don't want to leave it there. That's not simplified. Anything to the 0 power is 1. So negative 6 times 1 is just negative 6. So my answer, my simplified answer is negative 6, y to the 3rd. All right, for number 5, looks a little weird. I have 10 divided by 4, which 4 doesn't go into 10 evenly, but I can simplify that, and that's going to end up being 5 halves. All right, then I've got x's, y's, and z's. So I'm dividing, so I can subtract. So 3 minus, oopsies. 3 minus 2 is 1. So I have x to the first power, and I don't have to write the 1, so just x. Then I have 2 minus 3, which is a negative 1. And then I have 1 minus 1, which is 0. Okay, so now my 0 goes away, because that's just 1. Okay, so this is my answer, except can't leave a negative there. So now to make my negative a positive, I have to move this down to the bottom. All right, so the x can stay up top, but then y to the negative 1 has to move down to the bottom. Now in this case, I have a top and a bottom. So that means that the x can stay up top with the 5, and then the y has to go to the bottom, and it becomes 2y to the positive 1, and you don't have to write the 1. All right, for number 6, getting uglier and uglier. All right, I have a 3 and then no other variable or no other number on the bottom except for technically the 1 that we don't have to write. So that 3 is just going to stay. That's going to be part of my answer. Okay, then I got x's. So I have to do 3 minus negative 4. Right, don't mix up your signs. So if I do that, I have top minus bottom. So 3 minus negative 4. 2 negatives become a plus. So 3 plus 4 gives me x to the 7th. Okay, then I have, there's 2 ways of looking at it. I can do negative 1 minus 0, which is just negative 1, or I can go ahead and get rid of these zeros right off the bat. They're just 1, they go away. So I have y to the negative 1, z to the negative 1. Okay, can't leave negative, so the y and the z both have to move down to the bottom. Right, well in this case I don't really have a bottom, okay, because I don't have a fraction, but remember this is like 3 over 1. So that means up top I have 3x to the 7th, and then on the bottom I have 1 times y to the first power, z to the first power, and you don't have to write any of those ones. Okay, for number 7. The best part about exponent rules in general is that it doesn't really matter the order that you do the exponent rules. Just kind of go with whatever comes first to your mind. Just make sure you're correct in your exponent rules. So for number 7, I could simplify what's on the inside first, okay? Or I could distribute the -2. Or what I'm going to do is I want to go ahead and get rid of this negative right off the bat because negative exponents are ugly and they're intimidating. So to get rid of the negative, I'm going to, well, let's kind of talk about one on the side. I'm going to change colors here. If I gave you xy or x over y to the -2nd power, and I went ahead and distributed that in there, that would become, x to the -2 over y to the -2, but I can't leave the exponent. So that means if I have a negative, it's got to switch. So the x would have to come down, the y would have to go up, and I would be left with a y to the +2 over x to the +2. Okay, and because they're both raised to the 2nd power, that's the same thing as saying x times y to the 2nd power. All right, now we don't have to do all of that, but that's how I can make this look like this. Oh, what am I doing? Woo! Y over x to the 2nd power. Goodness. All right, so that's how I can take this first one and get to this one. So what I like to do, and this is just me, you don't have to do it this way, is instead of having all of this negative stuff in between, I go ahead and flip my fraction to make that a positive. So then I'm going to come back over here to my example, and before I do anything, I'm going to rewrite this as 3yz over 2x cubed y to the -3z to the 4th. Didn't change anything, just flipped it. But now that's going to all be raised to the +2nd power. Right? And again, that's just one way of doing this. Now I'm going to take this 2 and I'm going to put it with every single thing inside that parentheses. So I have 3 squared, which is 9. Then I have y to the 1st power squared. So remember, we're multiplying, so that becomes y squared. Then I have z squared, right, over 2 squared is 4, x cubed squared, right, multiply, that becomes x to the 6th. Y to the -3 squared becomes y to the -6, and then z to the 4th squared becomes z to the 8th. Still not done, right? Might run out of room here. So I'm going to keep going. Now I cannot simplify 9 over 4, so I'm going to keep that fraction. So let's see, we'll come up a little bit. 9 over 4. Then I'm going to start subtracting. I don't have any x's to subtract. Ooh, let me extend this. So I'm going to leave the x to the 6 on the bottom. I don't have anything to combine there. I have a 2 and a -6. So that's 2 minus -6. Remember, doubles become a plus. So 2 plus 6 gives me y to the 8th. Then I have 2 minus 8. So that's z to the -6. Everything looks good except that z. So I got to move him down. So my answer is 9y to the 8th over 4x to the 6th, z to the 6th, because I moved it down and it was able to become a positive. All right, that one's an uglier one, right? But again, with exponents, you could have started by simplifying this if you wanted to. That's perfectly fine. Whatever comes to mind first, just roll with it. Okay, one more. Oops. Okay, I'm going to start the same way. I'm going to leave this guy the same for right now, and I'm going to take care of this negative. And I'm going to do that by flipping the fraction. So I'm going to end up with 3x cubed y to the -1 over 2xy squared times 4x over x squared y squared. All right, now I don't even have to, like, this is to the 1st power because I switched it, so I'm not even going to write it. You don't need it if it's to the 1st power because you're not doing anything if you're raising it to the 1st power. So I flipped it. That takes care of that guy. Now you could start simplifying this side and this side. I'm going to multiply. I'm going to go ahead and multiply the top and multiply the bottom. So 3 times 4, okay, that's going to give me a 12. And then I've got 2 times a 1, so that's going to give me 12 over 2. Then I have x cubed times x to the 1st power, so I have 2 separate bases, so that's going to become x to the 4th. All right, then I have a y oops, I need to extend my fraction because I have a top and a bottom. All right, y to the negative 1, I don't have anything to multiply that by, so I'm going to leave it. Okay, then I have x to the first power times x to the second power, y to the second power times y to the second power. And now I can simplify by subtracting, right? I'm going to start with my 12 divided by 2, so that's 6, right? Then I have 4 minus 3, that's 1. And then I have negative 1 minus 4, so that's negative 5, right? Almost looks good, except for this negative here. Got to move that one down. So I'm going to end up with 6x up top, and then a y to the 5th on the bottom, because there's nothing else on the bottom there. All right. Okay, the last thing we're going to talk about, the exponential, the only thing we're going to get into, is the graph. Okay, so our general form, and there's more to this that you'll look at later, but what we're going to work on right now is AB to the x, right? Where A is always going to be your initial amount, right? Or your starting value, how much you have at the beginning. And then your B is your base. Okay, that's also what we call a ratio, and that's what you multiply by each time. Okay, and then x is our variable. It's always going to be up there. Okay, the shape of exponentials, right? We start kind of low, and we start getting bigger faster. So, for example, if I was going to do, we'll talk about 2 to the x, right? 2 to the first power is 2. Then 2 to the second power is 4. Right, then 8, because like 2 to the first power is 2. 2 to the second power is 2 times 2. 2 to the third power is 2 times 2. All right, and then I do 2 times 2 times 2 times 2. And I keep multiplying by 2 every time as my exponent gets bigger. So that means I start off kind of small, because I go from a small number and I double it because I multiply by 2. Then I take that number and I double it and I double it. But then as my numbers get bigger, when I double it, they get even bigger. So this is going to kind of shoot up and go up really, really quickly. That's our exponential curve, right? But as it comes down, it's going to get closer and closer to 0, but never actually equals 0. So our graph has something on it that we call an asymptote. And it's like a bottom, like a boundary. Like our graph isn't going to actually get there. Okay, that asymptote is spelled A-S-Y-M-P-T-O-T. Okay, that asymptote, or asymptote in general, is a line that the graph approaches but never actually touches. Right? And again, we're not graphing them right now. We're just worrying about the equations. Right? Now you could be going up, right, by multiplying by a number that's bigger, or, let me switch colors, we could be coming down. Okay, so if we're going up, that means we're exponential growth. We're getting bigger every time. If we're coming down, that means we're exponential decay. It's getting smaller every time. Both of them have that asymptote, though. All right, so if I'm getting bigger every time, that means that I'm multiplying by a number bigger than 1, like 2, 3, 5, whatever. If I'm getting smaller, it really means I'm dividing by a number every time. But if I wanted to divide by a number, that's the same as multiplying by a fraction. All right, so I'm multiplying by a percent. And what I mean by that is off to the side here. Like if I wanted to divide by 2, that's the same as multiplying by 1/2. So keep that in mind. You can figure this out by figuring out what you divide by, but it's always something that you have to multiply by. All right, so there's kind of our gist of exponentials. What we're going to do is write the equation when I give you a table. Okay, so in these tables, I'm always going to give you your initial amount. That's when x equals 0. So my initial amount is going to be a 1, right? So that means a equals 1 here, right? For this one, a equals 16. And then for this one, a equals 10. So that's always the a part that we work with. The next thing I need, or the only other thing I need, is the b value. I need to figure out what I'm multiplying by every time. So the x's are always going to go up by 1. I'm looking at the y values. I'm seeing what I multiply each number by to get to the next one. Okay, so sometimes it's easy if you just, I can see from 1 to 3, I multiplied by 3. Right, and then I multiplied by 3 again, and then I multiplied by 3 again. So sometimes it's really easy to see it. So that tells me that my b, oops, not 8, I don't know where that came from. That tells me that my b is going to be a 3. So when I go to write my equation, I'm going to have ab to the x. Well, my a is 1. I don't have to write that. And then my b is 3 to the x. So my answer is 3 to the x. That's the equation that fits this table. All right. For the second one, I could do the same thing. I can figure out what I'm doing each time, right? Like I know now that I'm going 16 to 8 means I divide by 2. I'm getting smaller, I'm dividing. This one's decay. And then I keep dividing by 2, right? Oops, divide by 2. But remember, dividing by 2 means I'm really multiplying by 1/2. So b equals 1/2. Right? Now, a shortcut for figuring out how to find b, if you can't easily see it, is to take 1 divided by the one before it. So in this case, I would take 8 divided by 16, and then I simplify and I get 1/2. That's my ratio. For this one, I could do 9 divided by 3. That's 3, so 3 is my ratio. So if you can't quickly see it, just take one of your y values and divide it by the one before it. You got to make sure you go from the second one to the first one, or the fourth one to the third one. All right, so then for this second one, my a value is 16, right? And then I have a times b to the x, so then my b is 1/2 to the x. And the way that we do our multiplying is we just put b in parentheses. And you only need the parentheses if you have an a other than 1. Like here, I don't have to put the 1, so you don't have to put the parentheses. All right, and then for our third one, now this one's a little trickier. Okay, I know my initial value is 10, but then to go from 10 to 1, I divide by 10. Okay, then to go from 1 to 0.1, I divide by 10 again, because every time you divide by 10, you move your decimal left 1. So here, I moved it left 1 to get 1. Then I move it left 1 to get 0.1. Then I move it left 1 to get 0.01. All right, so each time here, I'm dividing by 10. Okay, but dividing by 10 is the same as multiplying by 1/10. Or, if you couldn't figure that out, pick 1 and divide by the one before it. So we could say 1 divided by 10. Can't simplify it, so that is my b. So then my equation's going to be y equals my a value of 10 times my b value of 1/10 to the x. All right. Now, going back to the getting bigger and getting smaller and the growth and decay, I can tell just by looking at my equation if it's going to be growth or decay. So if it's growth, the b value is going to be bigger than 1, like that first one. 3 is bigger than 1, so this one is growth. Okay, it's decay, right, if your b is between 0 and 1. Right, so basically if it's less than 1 for what we work at. So the 1/2 is less than 1, so that one's decay, it's getting smaller. 1/10 is less than 1, so that's decay, it's getting smaller. We say it's got to be between 0 and 1 though, because if I have a number less than 0, that means it's going to be a negative number. And if I have a negative number raised to a power, like if I had -2, I would keep changing signs. So I'd have -2 times -2 is a positive. But then a positive times -2 would be a negative. So I would keep alternating signs, and it's no longer an exponential. Okay, so if it's bigger than 1, it's growth. If it's between 0 and 1, or our numbers that are less than 1 here, it's decay. Okay, not every fraction is decay, so keep that in mind, right? If I have like 3/2, right, that's 1.5. That's bigger than 1, so that one's going to be growth. So don't just look for a fraction.